Okay, so let's see what you guys remember. I know you remember. What's the degree of this one? 75, 962, 3. And positive A. So degree 3 is going to have 3 directions. Positive A means that it's going to increase over time. So start low, end high. Again, I don't care about the size of your bumps here. I just need 3 clear directions, starting low, ending high. If x approaches negative infinity, y approaches. If x approaches positive infinity, y approaches. Okay, so top line is the left arrow, which is down. Right arrow is up. Anything on that one? You guys good? We've been practicing this enough, I hope. Okay, now go down to number 15. Find all zeros. Some really wonderful person has factored this for us already. We love that. So thank you, mysterious wizard factorer that came before us and put it in factored form. Do you guys, anybody remember what I said I was going to teach you this week? How to factor something above a squared. That's my goal. By the end of the week, you'll be able to factor things that are above squareds. It's going to be exciting. Super important skill. But anyway, somebody did this one for us. So I set it equal to 0 because it says find all zeros. And then zero product property. I bet you half of the class at least can look at this and go directly to -1/2 without showing any work, and that's totally okay with me. But this would be one single real root. But Mrs. Talbot, the directions say find all zeros, not roots. Oh, but wait. Zeros, roots, and solutions are all the same thing. Interchangeable vocabulary words. Isn't that awesome? Okay. +5 plus 5. X squared equals 5. Square root. X equals plus or minus root 5. Okay. What is this called? Not complex because there's no I. 2 single real roots. They're still real. They're just gross. Let me show you how gross. They're still real. They're just horrible decimals that you don't want to graph or deal with, but still real. If it was I root 5, something with an I in it, then we would say complex. Okay. So moving on, I do not think that you, oh, actually, no, I lied. If you could find tonight's homework, please. Tonight's homework is this. I am not going to stamp this until Friday. However, I need you to note 2 things. First, we do not have access period this week. So if you have questions for me, they have to come tomorrow. Second, we are going to do our quiz in an unusual time on Friday. We're going to do it at the beginning of the period. Okay, I know. What? Okay, so, but I'm going to stamp first. And you can study while I'm stamping, but then we're going to do the quiz, and then we're doing like a whodunit thing. So That just throwing all that out there. Okay, now number one and number two, um, unless you just, researched ahead, you don't know how to do those two yet. By the end of the day today, you will. For surely tomorrow. Number five, well, three, four, five, and six. Hey, you're like, I know how to do these. You do, except I've thrown a little bit of a difficulty into these ones. These ones are not all nice factors. This is going to require your best friend. Do you know who your best friend is? You're, I was being sarcastic. Quad formula. Yeah, sarcasm best friend. This guy here, probably quad formula. This guy here, most likely quad formula. Do you see how they're trinomials, which means that they were not factorable? So you're going to have to use that to figure out whether or not they're real or complex. Your graphs for these might not look exactly like the answer graphs because you don't really know where complex number roots are. You know it's a little fake out dealio, but you don't know the location. So if your graphs do not match exactly, it's totally okay. Um, Now, do you guys know how to do these two? Are, we did these last week. Solve for A. You know what I'm talking about? Okay. And then these ones are like the ones on your worksheet, except for that now you're adding in the solve for A, but this one says factored form and this one says standard form. So you don't have to do standard form for all of them. Just read the directions. Alrighty? Okay. I will come back to this tomorrow and answer questions. For now, have a good old fun time setting this up. Setting up doctors you're so excited to set up this morning. Um, I have a question for you. What operation do you suspect that we are going to do in problem 85? So your choices are addition, subtraction, multiplication, or division. Number 85 that you set up right there. What what operation is that problem most likely going to be? What do you do when you do a box usually? What did you do on all six of those homework problems? Multiplication. Okay, so that's what I'm looking for. I'm looking for you to understand that a box, math one style box, meaning going forward, taking parentheses and getting rid of them is multiplication. Okay, what we're going to do in the next 3 days is backwards. So we're doing division. I need you guys to all understand that factoring is division. You might not have thought of it that way before, but if you think about a GCF problem, like, don't write it down, but if I were to do a very simple GCF, Guinan would be happy. If I did something like this, and I made it this, that is in fact dividing by 2. Does that make sense? Okay, so I need you guys to understand that factoring is division. And what do we usually do when we factor a quadratic? We do diamond and box, right? Okay, so we're going to do something similar when we do anything above quadratic. Okay, now it's going to look a little weird. So this box here, 84, is strictly vocab. We're going to have our original problem on the bottom now. So when you have the problem, instead of putting it on the top and the side, you're going to put it on the bottom. And in a division problem, this is called the dividend. These are fourth grade words you probably have not used since then. Maybe you have. I don't know. If you're at home talking about dividends, you could be if you're talking about money. Much more likely you talk about dividends then. But anyway, what you're dividing is the dividend. Okay. Now you're going to put over here is going to be a factor, and that is called the divisor. That's what you're dividing by. This is a factor. This is a factor. You're used to seeing those over there. It's not a big deal. And then on the top is going to be your answer. Does anybody remember what the answer of a division problem is called? Starts with a Q. Quotient, nice. It's the only Q-related math word I've ever learned, Mrs. Talbot. Okay. And then if you remember, when you do fourth grade division problems, sometimes there's a remainder. This box is going to be not the remainder itself, but this helps you get the remainder. Okay. So there's your vocab lesson and sort of how your setup is going to be. But before we do that, I'm going to do a fourth grade division problem to remind you of the process. Tomorrow, when we do the notes for polynomial division, I'm going to do the same problem with a box and with long division. Some of you are going to prefer the long division. Some of you are going to prefer the box. Okay, let me take that back. A majority of you are going to prefer the box. A few of you are going to prefer the long division. It's fine. It doesn't matter either way. My son hated the long division. He got all the way through calculus without ever having to long divide. He did the box. So if you love the box, it's fine. But anyway, okay. So we have a little thing that we use to help us remember. And maybe this will jog your memory from fourth grade. The D is divide. So you divide the 3 into the 29. and it goes in 9 times. So the D is divide. The first step of division is divide. Huh, how weird. Okay, M is multiply. Then you multiply those two things and you put it underneath. The S is subtract. Subtract the two numbers. And then the B is bring down. When you bring down the next number. And then you just go again. So divide. 3 into 20 goes 6 times. Multiply. 6 times 3 is 18. Subtract. And when there's nothing to bring down, that helps you get your remainder. So in this problem, there's remainder 2. And I don't know if you guys had the kind of teacher that let you put R2 there for like a week before you figured out what to do with it. And you're super excited, you just put R2. Anybody remember? Okay, now that's not actually what the answer to the problem is. Later on that week, they told you, don't put R2 anymore. Take the 2 and put it over the divisor. And that was your final answer. So you took this and you put it over whatever was outside the division. And that was your final answer. Did you guys do division with boxes though? Like with numbers and boxes, did you like this still? Or did you just not do it? I don't know. I don't know what they do in 4th grade anymore. There's a lot of S. Well, you know what? You don't need to do this really ever again. So, okay. Now we're going to do what is very comfortable for you. We're going to do multiplication in this box here. So just a reminder of how boxes work. Gosh, we haven't done any of these lately. Kidding. So 8x to the 4th, 12x cubed, negative 4x squared, negative 10x, negative 12x cubed, negative 18x squared, 6x. And you're thinking to yourself, why? We did boxes this weekend. We've done boxes since 9th grade. Okay, some of you are in 9th grade, done them since 6th grade. I don't know. The whole point of doing this was for me to remind you that like terms typically show up on the diagonal. So I'm going to use a red pen to highlight those like terms as we go. This is a key skill for you to identify when you're dividing. You need to know that the like terms are going to be on the diagonal. So final answer, 8x to the 4th. The x cubes cancel. You have minus 22x squared minus 4x plus 15. Okay. Now, number 86 is really my favorite problem of the day because it's a puzzle. I like puzzles. I'm going to do all of the missing pieces of the puzzle in red. So this is the original problem. And I'm going to use red for all of the bits that we write in after we figure it out. Okay, so if this box is 2x to the 4th and there's x out here, what has to be up here? 2x to the 3rd, beautiful. Okay. If that is 2x to the 3rd, then what does this box have to be? Negative 8x to the 3rd. Okay, everybody good so far? Okay, now what's another box we can figure out? This one? This one? This one's positive 8x. What's this one? Negative 2x squared. Okay, does that make sense with the answer down here? Does it jive with the answer? Yes. Okay, so what does this box have to be? 4x. Okay, why does it have to be 4x? Yes. Okay, so we got all that part. Okay, now what has to be up here? Yep, negative 3x squared, negative 3x cubed. Okay, if you can do this, then you can do the lesson. If you can figure out the missing pieces, that's all that you need to be able to do to learn how to divide. So next thing we're going to do is actually divide. Yay. To leave these up here because they're going to help me work backwards. So I know it's kind of at the bottom of the screen for some of you. Sorry about that. I want to teach you is what size box do I need to do this division problem? And this doesn't always work. It works most of the time. Sometimes it doesn't work. The times when it doesn't work is when stuff cancels out. Um, it's not a big deal because if you have too many boxes, you're just not going to use the last couple. And if you don't have enough boxes, you just draw on a couple. It's not a big deal. I am a person of Virgo. I've explained this before. I like to have everything like linearly set up. So this is the only reason that I would even like, if you had Mrs. Aragon back in the day, in the past, she was the teacher next door. She's one of those people who like wants you to think like she's gonna explain all the why. I cut to the chase. She's not a cut to the chaser. Anyway, she would be like, well, just figure out if you want to do a pattern and just draw more if you need them. And I'm just like, no, I want to know the shape of this thing before I start. Okay, so for me, bilinear Virgo thinking, I want to know what size box I need. Again, works most of the time, not all of the time. No big deal because we have erasers and pencil. Okay, so the box I need is going to be 3 across because of the degree 3 polynomial here. And then 2 tall because this has 2 things in it. Let me say that again. The size box I need is going to be 3 by 2. And it has to do with the degree of this and how many things are in here. Okay, so that one is going to be a 3 by 2. So draw me a 3 by 2. You can draw it vertical or horizontal. I'm going to do it horizontal just because, again, linear thinker. Okay, and I'm going to take the divisor and put it over here. And instead of putting this on the top, I'm going to put it on the bottom. Now, hold on. Do you guys all see that there are four? This is so dumb. This is my Virgo-ness. Again, you do not need to do this. But do you see how there's 1, 2, 3, 4 little spots at the bottom of this? I like to line up these things 1, 2, 3, 4 underneath that. So let me see. What I'm showing you is under this line, I like to put the 6x cubed. Under this line, I like to put the 7x squared. Under this line, I like to put the negative 16x. And under this line, I like to put the 10. Giant, giant nerd pants over here. Do you have to do that? No, not at all. Okay. Now, taking a look at the answer down here, I want you to notice that in the first box was always the same thing. So 2x to the fourth is here, 2x to the fourth is here. 8x to the fourth is here, 8x to the fourth is here. So if 6x cubed is here, that means 6x cubed is going to be here. And then we just do what we did in number 86. Okay, so what does the top of this have to be? 3x squared. What does this have to be? 15. Okay, this is the moment of truth. If you can do the skill that we do in the next 2 seconds, you've got this whole lesson and we can be done. There are 7 total x squareds. I have 15 x squareds. I have 15. I only want 7. So I need to take away 8x squareds. What? Oh, on the top? Sorry, you're a step ahead of me. Okay. Now, I only want negative 16x's, but I have negative 20x's. So I need to have negative 20. I only want negative 16, so I have to add 4. Yeah. You're already doing the top. And if it divides out evenly, this box will match this number, and you're going to be very satisfied and happy. Okay, now the answer to this problem is 3x squared minus 4x plus 2. The answer is the top. However, you might see this problem written in different ways. This is the normal way of writing it. You might also see this. These two things are saying exactly the same thing. They're the same problem, same setup, same answer. They just look different. Okay, there's another one that's you're not going to like. This is saying the same thing as this, which is saying the same thing as this. These three things all say the same thing. This is just saying, oh, it's a negative 1 exponent, so it goes to the bottom. Just a reminder of what that means. Okay, now they all have the same answer, which is 3x squared minus 4x plus 2. Okay, last one, number 88. It's going to feel like very familiar to 87. There's only one thing that's different about 87 and 88. find the difference. First of all, you can see that I wrote it wrong the first time and had to white it out, fix the difference. Oh, you like my joke about that? My joke is about that. So anyway, do you notice that there seems to be more ones tiles in number 88 than there is in 87? How many more ones tiles are there? Eight more ones tiles. Okay, what that means is it's probably not going to divide evenly and there will be a remainder. So my goal for number 88 is to teach you what to do with the remainder. Because that's it, then you know how to do it. Okay, so let's practice this again. I sit down to this problem, I say, okay, degree 3, 2 things, that's going to be a 3 by 2. I'm going to pretend I didn't do almost exactly the same problem up there. Okay, 2x plus 5, divisor on the side, dividend on the bottom. Okay, starts out the same way. So I say to myself, okay, first box is always the same as the first term in my original polynomial. So 6x cubed down here, 6x cubed up here. This has to be 3x squared, which means this has to be 15x squared. Okay, then I say to myself, I have 15x squared tiles. I only want 7, so that means I need to take away 8x squared tiles. Really quick, anyone in here notice that I'm doing divide, multiply, subtract, bring down in a box? Just saying. It's the same thing. Anyway, so this has to be minus 4x. So this has to be minus 20x. You're like, yeah, we knew that, Mrs. Taba. We just did this problem. Okay. So negative 20x. So I have negative 20. I only want negative 16. So I'm going to balance that out by adding 4x. So this has to be 2. And this is 10. And then I have a very unsatisfying situation. Oh no, there's a remainder. And it isn't a big deal. It's just like you just need to know how to deal with it. Okay, this is what you do for a remainder. You take the tiles from your original polynomial and you subtract the last box. Now, you guys kind of knew that. There are 8 tiles too many. That's why we did exactly the same problem again, because I wanted you to like understand that that meant there were 8 tiles over, so the remainder is 8. I like to put an arrow in that direction because students are always like, do I subtract this or do I subtract that? I like to make a little arrow just showing the subtraction there. And then remember how I said you only got away with writing R2 or R8 for like a week. And then the teacher was like, no, you don't get to do that anymore. So what you do is you write the answer. So the answer is 3x squared minus 4x plus 2. And remember up here, we took the remainder and put it over the divisor. So we're going to go plus, because this is a positive number, 8 over 2x plus 5. So remainder over the divisor, just like long division. Unsatisfying. I like it when they come out evenly and I get to do my little check mark.